Let's talk about friction. You guys just got done with a lab over friction where you had to investigate what friction is, what it does. And you're probably already familiar with it, but just to clarify, we know friction is a force that opposes motion or intended motion. Now, like all forces, friction causes acceleration, but you have to pay kind of special attention to friction because it's not always there, and it changes depending on what's going on with the object. Because if the object is sliding, then we have kinetic friction, and if it's at rest, then we have static friction. But we don't always have static friction. Okay? And what I mean by that is if you consider an object that is not in motion, and so we have this thing just sitting here on a surface, and two forces act on it. The normal force is going up, and gravity is pulling down. Those two forces balance each other. They're in equilibrium. Nothing else is acting on this crate, which means it's not going to accelerate. So static friction isn't here either. If static friction was pulling in some direction, it would unbalance the forces and this would start to accelerate. And friction is never going to make something accelerate. It's going to try to prevent motion. So static friction isn't here yet. But if I try to make this thing slide this direction, if I try to drag it across the surface, when I start applying force, as soon as I do that, static friction pulls against me, and it balances my force to prevent this thing from moving. So now I'm trying to make it move, and static friction is opposing that applied force, and it balances it. So this thing does not start to slide. So that's what static friction does. It acts to prevent an object from slipping or sliding. And it will match me. The harder I pull to the right, the harder static friction is going to pull to the left until I can exceed the maximum static frictional force. And when that happens, then this thing starts to slide. So there is an upper maximum to the static frictional force. Now, kinetic friction applies if the object is already sliding across the surface. Okay? So if I have this thing here, and let's say it's in motion this way, maybe I gave it a good shove and it started to slide, then I still have gravity pulling down, and I still have the normal force lifting up on it or pushing up on it. But now, since it's moving to the right, kinetic friction is going to be to the left, and it's going to be trying to slow this thing down and stop it. Now, I could keep it in motion if I apply an equal force to the right. I could make it go faster if I apply a greater force to the right, or it could slow down and stop if the kinetic frictional force is the greater force. And when kinetic friction acts, it's important to realize these two surfaces have to be sliding past each other, and we'll talk about that in a minute. When I mean kinetic, we think about in motion, but you have to pay attention to what we mean when we say in motion. And so kinetic friction is generally smaller than static friction, and so to illustrate what I mean when I say motion, you have to be careful. If we have a tire here, and it's rolling across the ground. So let's say it's rolling this way, not sliding, not skidding, just rolling along the ground, then it's not actually experiencing kinetic friction between the ground and the tire. It's static friction because this point's in contact with the ground, but it's not sliding across the ground. And a little bit later, this point's going to rotate down and it'll be in contact with the ground. It won't slide either. And so that means that it's static friction. But as soon as this thing starts to spin or slide, then it's kinetic friction. And since kinetic friction is smaller than static friction, you're better off not to have your tires locked up. You're better off not to be spinning your tires because you have a greater frictional force when the tire is in static mode, when it's just rolling across the ground instead of sliding across the ground. Now, next up, we're going to talk about the coefficient of friction. How big is this frictional force? Well, if we think about it, the normal force is actually the force that's responsible for creating friction, because the normal force is from the surface pushing up into the object. So the normal force is the force between these two surfaces, and it's that force that gives rise to the frictional force. And so what you guys learned in lab was that the frictional force is equal to the normal force times the coefficient of friction. And we can change this to static and static or kinetic and kinetic, but this is generally what we have. Or you could say that the coefficient of friction is equal to the frictional force divided by the normal force. Now, what do these two things mean? Well, essentially, it tells us what the coefficient of friction means. Since the coefficient of friction of rubber on dry concrete is 0.8, it tells us 80% of the normal force is the frictional force. The coefficient of friction has no units. If you look at this equation, it says force is equal to force times this coefficient. That means this coefficient's dimensionless. It's just relating how much of the frictional force is the normal force. And so it has no unit.